We start chapter 11 looking at another type of test. This one's called the chi-square test. We'll explain what that is in a little bit. But really it's the idea of being able to see if an observed distribution fits, right? If an observed distribution fits an expected. So you have an idea that you want to see, you're going to see something, right? This distribution of values for some variable, right? And then you have an expectation, and then you actually have the observation. Do you see what you think you're going to see, right? And it's kind of a common question, right? Is something, this idea of unusual played a role in our previous tests, right? Did I observe something that was unusual here? We're going to expand the idea to look at a question such as M&Ms, right? The company claims that the distribution of colors fits these numbers here: 24% blue, 14 green, 16, let's see, 14 brown, 16 green, 20 orange, and so forth, right? So if you open up a bag of M&Ms and you observe what you get out of the bag, would you see this distribution, right? And so that's the kind of test we're going to run, called the chi-square test. Something to think about would be, and again, we don't have a chance, we're not in class to discuss this, but this idea of what do you think the distribution of income is in the country? And this data is from 2019, right? What percent of people you think fit each of these categories, meaning that when they file their tax returns, this is the amount of money they indicated they earned, right? What would the distribution, right? And then also think about how many people, if you know that there's 260 million people, right, that in this data set here, how many people would fit that category? So that's the idea, right? If you, what would you expect to see? And then what was the observations, right? And so on the second page of our notes, I have that distribution. So you can kind of compare that. But here is a distribution of income. What would we expect? Compare the expected to the observed here, right? To see if it matches up. That's the kind of test we're going to run. Goodness of fit test. It's called the chi-square. I wrote it how you would say it, chi. It's not chai, but chi. And we calculate a test statistic depending upon our observed values and our expected values. You put them together and sum them all up, and that would give you what's called the chi-squared statistic. We don't get into really the technical details of a chi-squared distribution, right? There's degrees of freedoms with it, but if you graphed out a chi-square distribution, it depends upon, of course, degrees of freedom. What's the number of categories we're talking about? So in this original M&M's problem, we're talking about 1, 2, 3, 4, 5, 6 different categories. And so that's what we're going to be looking at. And then we calculate the p-value again, right? What's the probability of observing that chi-squared value under our null hypothesis, which we'll talk about in the next section.